Yes, it's visible, right?
Yes, sir.
Yes, sir.
Okay. So today in the session, we are going to start with the software, which means how to create a simple model. What will be the starting basics for creating a simple model? What are the things we need to consider? And after creating a model, what are the things we need to consider? All those things we will be discussing in today's session. Okay. I hope you know how to start a plant simulation, right? So this is the, where is it one? So this is the software, and once we open this one, there we will be having this model, create new model. So if you click one, then it will be asking whether what type of model you want to prepare, whether it's a 2D model or a 3D layout. Initially all the drawing starts with a 2D only, so I will be using 2D. Now what is this one? What is this area called?
The class
Class
library.
library. Class library.
What is the purpose of class library?
It basically tells about the structure of the program.
Yes, okay. It basically defines the structure of the program. So how to define a lengthier programs, all the things will be discussed in this one. What is the purpose of this one? Toolbox. What is the purpose of toolbox?
So it has all the tools that are used in making a simulation.
Yes. For creating a model, definitely there will be need of some tools. So the tools will be derived from this toolbox. Okay. Next, what is this one?
Model frame.
Yeah. What is the necessity of frame?
So all of the simulation will be made on the model frame. All the tools will be placed here, and then the simulation will be made on the model frame.
Yes. For creating a model, they should be having some medium. I mean, some sort of representation that will be considered as a frame. So we are going to prepare what are the component, what is the layout, all the different things in this frame itself. So we'll be considering this as the main platform for creating a model. Okay. Now today in this model we are going to start with a simple model. So what will be the input of a plant?
Raw material.
So if at all I want to start a model in the plant simulation, then definitely there will be two things that will be needed. First one is source. Source is nothing but input. Okay. So for clicking that one, so you need to just click on this toolbar once so that it will be selected, and wherever you want you can again click it. So it will be posted. So if you want to drag it, then click it and drag. Hold the leftmost button on the tool and you can drag wherever you want. Okay. So if you want to, there will be no any options for zoom in zoom out in 2D, so it won't be possible. So if you want to move the layout, I mean pan it, that will also be possible in 3D, but in 2D once the model, this is the fixed layout. So here you can drag this item, but you cannot zoom in zoom out, at the same time you cannot pan it. Okay. First one, so click and drop. Next one, same, I need a output, so that is called as a drain. So click and click it, so it will be pasted. So for any plant there will be need of only one source and one drain for a standard basics. Now I am having input with me, now I am having output. Now what is the thing I need here?
Process.
Sorry, state.
Okay.
Process.
Yeah, process. For process definitely there will be needing of some missions. Here we are going to start our model with some three missions. Okay. So for that you need to click this one, station, and click here, station, and again click it and drop it, click it, click it. Three stations. Now you want to align, I want to align them in a straight line. For that there will be two methods. First one is directly drag and drop like this, so that they will be placed in a line. So even we don't know whether they will be in a horizontal or not. So if at all you want to check that, then there will be one method for doing that. Okay. Do like this. Okay. Hold the left mouse button and drag all the items, or hold the control button and click each and every icon. then right click on your mouse, then there will be a pop-up. Okay, in that pop-up there will be an option arrange icons. In that icons there will be align horizontal, align vertical, distribute horizontal, distribute vertical, reverse order, lot of things will be there. First I want to align them, so arrange icons, align horizontally. Now all the icons are arranged horizontally. Okay, if I want to align them, see one more thing here, in the software there will be no any undo option. Even though if you press Ctrl Z, you won't get anything. So once there will be an error, then you need to delete that. That's it. Again I am posting them here. I will be showing you. If at all I want to place them in a straight line, then drag like this, right click, arrange icons and align horizontally, so that they will be arranged horizontally. If at all I want to place them, see, different icons vertically, then drag and drop all the items, right click, arrange icons, align vertically. All the icons are aligned like this, but some are overlapped here. If at all I want to differentiate it, then I can do that also. See, now I am defining it, source here, drain here, drag and drop, arrange, align horizontally. Now see, the distance between these two is this much, some x units, and distance between these two stations is y, and again it will be some z. So I want to distribute equally. For that, so drag everything in and arrange icons, and there will be one thing, distribute horizontally, so they will be equally distributed in between source as well as drain. Okay, see, again I will be, now I will be selecting everything, right click, arrange icons. First you need to align them. I have aligned them, then right click, arrange, distribute. Now they were distributed horizontally. See here. Okay.
Sir, it will distribute in equal distances, but
Yes.
suppose we want to change the distances, means that equal distances also we can increase or decrease or not.
Yes, you can decrease. There will be having some, I mean, tools for that also. If at all you want to maintain some distance, everything will be distributed horizontally. At the same time, these two distances are somewhat apart. That can also be possible. Okay, there will be some tools. I will be explaining that in the later phases. Okay, first this one. Now I have done this one. Now I want to align them vertically. Now see how the vertical will be happened. Align vertically. Now I have aligned. Now I want to distribute. See, distribute vertically. If I place source here, then click here and align, distribute vertically. So they will be equally distributed. Okay, fine. Now I don't want it. So I am selecting each and everything and delete. So if I don't click this apply, what will be happen? It will be deleting each and every icon simultaneously. I mean, step by step. So if I click this one, everything will be vanished in a single go. Okay, now I want to start a model. For that, this is my input and this is my output, and I will be using three different missions, 1, 2 and 3. I want to distribute horizontally everything. So first, what happened, see, this is what will happen. If in, out, 1, 2, 3. Select everything, right click, arrange icons, align horizontally. Right click, arrange icons, distribute horizontally. Fine. Now this is my source. If at all you want, you can use the source name. Or if at all you want to change the name, then right click on it and there is a rename option. You can directly give input input. Okay. So here, see one more thing here. If you give space here, input space 1 to, space is not going to work here. Okay, input 1, it is possible. Input space 1, it is not possible. So if at all you want to give some space, then you need to use some underscore 1, input 1. Okay, similarly station also, station 1, station 2. Now I don't want like this, I want to rename it. So right click, rename, and I will be using m1. okay, and this one will be m2, okay, and this one m3, m1, m2, m3, and instead of drain I want to change it to output, output. Okay, now see, now I have defined each and everything here. So there will be having all these things like input, output, and there will be having three missions. Now can I run the simulation?
No, sir,
So
because we have
No,
not
sir.
connected.
now the mission, I mean the industry is having input ready and output is waiting. All the missions are ready. Now what I need to define? I need to define a process. That process is nothing but connectivity, connectors. So I need to connect these two. Then only a process will going to happen. So I am using this connector. Okay. Again, same thing. So if at all you want to use this icon, then you need to click this one. Again, see here. If at all there is, I mean, there is a problem with you, then here there is a representation. Left click to insert the object connector. Hold down the control key to insert multiple objects, or right click to cancel. If at all you want to do that, then click on the connector. At the same time, what is the first icon you want? So this is the first icon. So you have clicked this one. Next, so which icon you want to connect with this one? M1. So go to M1 and click on it. Done. Same. Again, second connector. Now what is the thing we want to connect? M1 and M2. So click on M1. Again, go to M2 and click. Same with M3. Click and go to M3 and click it. Same. M4.
Sir, we have only straight line connectors, or we can means use U shape or any other also.
That will be possible in 3D. Okay. So if there is a, I will show you. If there is a mission is there, and connector will be straight only. See, connector will be straight. Why? Because it is not any sort of material transport. It's just a connection. So connection will be represented with a straight arrows only. So if there is a conveyor, if there is a footpath, that can be possible with the, I mean, curves. If at all you want to connect these two with some curvature, that will be possible with the connect, I mean, this conveyors and all those things. But connector is like, it's like a illusion. Here this machine is connected to this machine. So which means once the part was ready here from M1, so automatically it will be entering into station. So here this is like a relationship we are giving. Okay, how the material transferring, that we are not defining here, we are just defining. So there is a relationship between these two, that's it. What type of relation, how the material handling is carrying on, that we are not talking as of now. Okay, that is why this connector will be like a straight arrows only. It's just a representation, that's it.
Okay, sir, got it.
Now see, fine. Now this thing, now can I run the simulation? Is the model finalized?
Yes, sir.
Yes, sir.
See, now I'm having
Yes,
input,
sir.
output, and three missions. Everything is connected. So this mission was perfect. Now, if at all I want to check whether this was connected or not, then select everything. See, there is a green button here, green and green, which means these two are connected. Green and green connected, green and green connected, green and green connected. If all the parts in this diagram are in green, then it means it is connected. Now I will be deleting this one. Now see what will happen. Connected. There is no any relationship between these two. That is why it isn't connected. Okay, we can check like that also. Now if you drag everything, see everything is in green, which means it is connected with this one, connected with this one, connected with this one. Now the model is connected. Now I have the model. So now I want to simulate it, I mean I want to test it, I want to run it. For running it, so we will be having this event controller. With the help of event controller only we can run the simulation. Okay, so we can drag here wherever you want. So you want to, can you place here, you can place here, you can anywhere you can place. Now I am placing here. So there is a event controller. Now you need to double click it. Now the event, see this is what exactly the pop-up. Here with this thing you can control the complete simulation. Now what is this one? What is it, slower, faster?
So the rate at which our processes will be done.
Yes, So simply speed of the simulation. You want to regulate the speed. How we want to see the simulation. So whether you want to see the simulation in a faster manner or whether you want to see in a slower manner, that can be defined by using this one. Okay. For starting a simulation, for running a simulation, you need to double click on this one. Then this pop-up will be opened. Here, first thing you need to do is you need to reset the simulation. Okay, once the reset was done, then you need to decrease the speed so that you can clearly see, it is visible, clearly visible how the material is transferring from one station to another station. So I have reduced the speed, and if you want you can click this one. So if you click this real time, what will be happen, the material will be clearly visible from station to station. Okay, so I am clicking this one and reset it. I want to run it. So this is the start and stop. So I want to start the simulation. See here, from input material, here, here. Okay, it will be continuously moving. So here time, this is what
सर मूवमेंट विजिबल तो नहीं हो रहा.
visible माने 2D में इसी तरह दिखता है. If it is a 3D or if we are using a conveyor here, then the material handling between station to station is visible. That is why I have told you in the starting. So this is connector just a representation, which means this machine is connected with this one. Once the part is ready with M1, so automatically it will be entering into this one. This material handling cannot be visible, is not going to visible with these connectors. So instead of this connector, if at all you are using some conveyors or something, then the material handling, the material movement is also visible with those things. Okay, generally we are going to start the model with this only, I mean with the connectors only. Once this model is working perfectly, then we are going to replace this connector with different modes of transportation. Like we can use conveyors, we can use human, we can use a pick and place robots, we can use some other AGVs, forklifts, some other different applications for material handling. Okay, initially we are going to use these connectors
Okay, sir.
whether to check material handling is perfectly running or not. Now I am resetting.
आउटपुट का तो कोई सिग्नल नहीं मिला कि आउटपुट पे आ गया है वो.
Yes, I will tell you that also. Now I run the simulation. See here, the part up to this 1, then 2, after this is 3, and it is entering into output. So there is no any representation. Why? Because there is no any extra connection from the output. So the output is like a store, so it is not visible. Even though if at all you want to check, so what is the type of material, how many material enter into output, for that, so this simulation, that I will explain you. Wait, first we will discuss about this simulation. See here, it is running for 1 minute 30 seconds. This is, see, if I run the pause this one, there will be this one. 2056 is microseconds, 40 is seconds, 1 is a minute. So which means it will follow microseconds. So leave the microseconds, seconds, minutes, hours, days. This is what exactly the simulation will follow. Now if I run the simulation, it will run like this. If I increase the speed, see, when it will going to stop? What is the end date of the simulation? Have we defined that?
No,
No,
sir.
sir.
We haven't defined. That
No,
is
sir.
why, see, this simulation is running continuously. This is seconds, minutes, hours, days. This simulation is running for 2 days, 13 hours, 18 minutes, and 1 second. So this simulation is continuously running. If at all I run this again, so it will be continuously running. It won't stop at any point. Why? Because we haven't assigned anything here. Okay, that is why it is running like this, which is not at all correct. Okay, we can check like this, but this is not the correct method. If at all you want to run the simulation for a particular time, then you need to stop it, reset the simulation. Okay, decrease the speed. Then there is a one more tab here. This is controls tab, and there is one more tab, settings. In the settings tab, see here, date is defined, so date. So once you have defined the date, it will be, date will be visible. So if at all you want to change the date, then 2022 2, and today's date is 8, and time you can define, time is nothing but 10 10. From 10:10 the simulation is going to start. Okay, this is the starting time. End time, at what time you are going to run of the simulation? I want to run the simulation for 2 hours. 2 hours will be denoted in different manners. You can represent by using seconds, you can represent by using minutes, you can represent by directly number 2, like that. See, for that, if at all I give 60, if I click apply, then it will be considered as, see, 1 minute 60 seconds. I don't like this. 45, apply. Now see, 0, 45, which means 45 seconds. If I give 90, it will be converted to 1 minute 30 seconds. If at all I want to give 5 minutes or 10 minutes, directly I can give 10, and if I click 10 and apply, then what will be happen? It will be considered as seconds. Now I don't want that one. So for that 10, if I press the semicolon, then it will be considered as 10 minutes. Okay, same 30. If at all I want to go run the simulation for 30 minutes, 30, apply, 30 minutes. Same with hours. If at all I want to run the simulation for 2 hours, then 2, I need to give 2 dots. 2 hours, 00 minutes and 00 seconds. Okay. If at all you can change it to 1 and 45. So which means 2 hours, 1 minute, 45 seconds. You can change it to 5 hours, double semicolon. So which is stating that 5 hours. If at all you want to run the simulation for 2 days, then what it will be? How it will be? Now you tell me. I want to run the simulation for 2 days.
Sir, we have to write it in a verb format.
2, 1, 2, 3. See here. Apply. So 2 days, 00 hours, 00 minutes, 00 seconds. Okay. Or else I can define like this also. 24 double dot. It means 24 hours. If I click like this, 1 day.
Sir, can you explain once code, please?
Okay, fine. If at all I want to run the simulation with respect to seconds time, okay, I want to run the simulation for 45 seconds, then I need to give 45 and click apply. What will be happened? See here, 0, 45. So 45 seconds will be considered. Whatever the figure you want, if at all you want to run the simulation for 10, then if I click, I mean, if you write 10 and click apply, so it will be denoted as a seconds only. So if you click 75, apply, what will be happened? 1 minute and 15 seconds, it will be considered like this. Okay, so if at all you want to run the simulation for 120 seconds, then 120, apply, so it will be considered as 2 minutes. Okay, if at all you want to run the simulation for 30 seconds, 30, and you need to give apply, so it will be considered like this. If you want to run the simulation with respect to minutes, okay, you want to run the simulation, or I want to run the simulation for 5 minutes, then for representing it, I can directly define 5 into 60 like 300 seconds, or else I can simply 5 and I can use the semicolon and click apply. So what will be happened? 5 minutes. Same, if at all I want on the simulation for 10 minutes, then same 10 and semicolon. Then it will be considered as a minutes. If I give only 10, what will be happen? It will be considered as seconds. If I give 10 and a semicolon, then it will be considered as a minutes. Okay, seconds, minutes, hours and days. Now seconds was done, minutes was done. Now I want to run the simulation for 2 hours. Then for that I need to press 2 at the same time 2 colons. Apply. See, 2 hours, 00 minutes and 00 seconds. Same, if at all I want on the simulation for 10 hours, 10, 2 semicolons, apply, 10 hours. Similarly, if at all I want to run the simulation for 2 days, then see, this is seconds, minutes, hours. After the hours, what will be happen? Next is days. So I can give 2 and 3 colons, apply. 2 hours, 00 minutes, I mean 2 days, 00 minutes, 00, sorry, 2 days, 00 hours, 00 minutes and 00 seconds. If you want all, you can change here, 2 hours, 05, 2 days, 5 hours and some 35 minutes and 45 seconds. See, I can define like this, which means this simulation, the model which I have prepared, that will run till, see, this is the end, which means this simulation, this model will run till this time, 2 days, 5 hours, 35 minutes, 45 seconds. Okay, I have defined this. Now see, I have defined this, apply. Okay, now I have defined the time. Now what I need to do, again I need to jump to controls tab, again reset the simulation and run it. See, this simulation will run. If at all I want to check the end statistics, then I can directly drag like this. Seconds, minutes, hours, 1 day. See, what is the time we have defined here? 2 days, 5 hours, 35 minutes, 45 seconds. Same. 2 days, 5 hours, 35 seconds, 45 minutes, the simulation is going to stop. Clear?
Yes, sir.
Yes.
See, for running any model in the simulation, there are only two methods to run a simulation. First method is this, with respect to time. Okay, the simulation will completely representing on the time only. So if at all you want to run a simulation, so you can run the simulation with respect to time. That is the first condition. In the first condition, you can define the time like this. So if at all you want to run the simulation for 10 days, apply. So 10 days. Now you can reset it and run it. It will be visible and you need to wait for some time, just for 2 minutes or 3 minutes, so automatically it will be completed. That is the this time. Okay.
Sir,
Yes.
in date column you have mentioned date and time as well.
Yes.
Like it will process will start at 10 a.m. So in this, do we follow 24-hour time slot or we follow 12 hours?
It's like a 24 hour
Like it.
slot.
Okay.
That is what exactly I have defined here. See, I hope you have remembered. So file, preferences, in the preferences tab there is this one, date and format. In yesterday's session I have explained you. So whatever you format you want, you can directly choose by using this one. So if at all you want, you can choose a 12 hours format, a 24 hours format, and the date format this also. So you can check that, you can directly use by using that one. You can change here, you can click and you can run the simulation. So simulation will work with respect to that only.
Okay, sir.
Okay, see, 8 days it was running. 9.
Excuse me, sir.
Yes.
Sir, when we are setting up a plant, means a plan for on the product basis, means suppose in one day we have to produce 4 products, and all 4 products take different times. So this means plant layout is on the basis of time,
Hmm.
means equal time. Every product is taking equal time.
Hmm.
So we have given starting time and end time.
Hmm.
But what if we have to produce a product which take different times?
That can also be possible. See, for this model, I am using this event controller. If there is some other model, some other frame, like you said, this is process 1. If there is a process 2, for that process 2, I can create a new model, new frame here, and I can run that with respect to that time. Okay, in plant simulation there is a capability of creating multiple frames. Each and every frame will be having different time characteristics. So you can run the simulation with respect to this time for this run. And one more thing here, time is common, I hope. See, for every model time is common. I have prepared these four, I mean, 1 2 3 3 missions and this process p1. This p1 is having, I am giving, I want to run the simulation for 1 day. See, I am giving 1 day, I want to run the simulation for 1 day. If I run the simulation, this will work with respect to time only. So one day it will work with respect to time. I mean, each and every mission is having some 5 minutes of processing time or 10 seconds of processing time. That doesn't mean anything here. I want to run this process for 1 day. With respect, I mean, I am not for, considering these times. So whether it may be for processing this part, it will take 5 hours. Then how many parts I am going to produce at the end of the day? That doesn't matter. I want to run the simulation for 1 day. That's it. The time is common for each and every mission. See, I am using some other thing here. Mission. Okay. Align horizontally, and I am using a connector. Okay, see there are two processes here. If I run the same thing, this one, delete. See, if I increase the speed, have you observed any difference between these two?
No, sir.
See, the missions and processing time, that is a secondary aspect. Here we are running the simulation with respect to time. Time is constant for each and everything. Time is common. Time is a like an absolute coordinate system. It is common for each and every mission, every process. So if at all I run the simulation for one day, so if this process is having only 3 missions, that doesn't matter. If this process is having some 6 missions or 7 missions, it doesn't matter. So based upon the missions, it won't be considered. So based upon the time only. At the end of the day, how many parts I'm going to produce with respect to this. At the end of the day, how many parts I'm going to produce with respect to this. That can be calculated by using this software. Okay. Even what you are saying, the time, that can be defined in the later sessions. So how to change the time of this one, if at all there is a different times. So m1 is having 1 hour, m2 is having 10 minutes, m3 is having 4 hours of processing time. Now in this condition, what will be the maximum output? Now in this condition, station is having 2 minutes of processing time, station 1 is having 2 minutes of processing time, whereas station 2 is having 5 minutes of processing time, station 4 is having 1 hour of processing time. Now according to this different processing times, now what will be happen to my production? How can I supposed to manage it by end of a day? That is a secondary, that is optimization part. Here we are in the creation, layout creation. Okay, this layout creation will work with respect to time only. Okay,
Okay, sir, got it.
fine. Now
And sir, for
yes,
example, if you want to create two products which take different times, so we will have to create a different frame for each of the product.
as of now no need. See, if it is a single plant, if you are preparing a larger model like I told you yesterday session, if it is a larger model which is having 10 or 20, 12 processes, now if you want to differentiate, then you can using different frames. Otherwise you can create here itself. Now see, I have created this many, control C and control V.
So now each of these will have different times or will have same time.
Now I have different, if at all you can change that also. See here, there is a 10 seconds of processing time. For this I can change it to 20 minutes. For this different processing times you can define in a single process. There is no worries in that.
Sir,
Yes,
sir, how you doubled this process?
yes, that I will tell you later. As of now, no, don't worry about these things. If I say the shortcuts, you won't be, it is not easy for you. Okay, first this model, I hope you understand. See, this is the input and this is the output. This simulation will work with respect to time only, right? So whatever the time you can define here, that will be, this is the end time. So which means this model what you have prepared, this will work with the time which we have given. This is the first method. Clear?
सर तो एक फ्रेम में एक ही इवेंट कंट्रोलर होगा क्या?
एक ही कंट्रोलर होता है. इवेंट कंट्रोलर इज कॉमन. इवेंट कंट्रोलर इज वन फॉर सिंगल फ्रेम. Okay, why? Because just assume, see, all these process are in a single industry. So for an industry the time is common, time is same. The material is coming at a single station, that is a common, that is same. That is why single event controller. If you want to differentiate that, then you need to create separate frame for that by using separate event controller. But in general, what will be happen? What is the model? I mean, the length of the model is large. Even though we will be having 200, 300 missions, there will be using only one event controller. Why? Because so the plant, we will call it as a takt time or a lead time, cycle time. All these defined when the input entered into the plant. When exactly that input entered here, that will be considered as a 000. So once the part will be dispatched from this input, so then it will be considered as a first second. So whatever the number of missions, see here, I will be having these number of missions, these many process. So after this, finally I will be collecting the result here. This will be my output, final output, different after completing different process. Then this is my first input, that is 0001. At what time I am getting this output, that is completely considered in the plant simulation. Not only the plant simulation, the plant also, we will call this as a takt or lead time, takt time, cycle time. All these things will be considered this only. Entering of a part into the plant, and at what time it will be exiting, how much time it will be in the processing. That is nothing but a controlled by a single event controller only. Okay.
Okay, sir.
Fine, don't worry. I will explain you each and everything in detail when the separate tool comes. Now, this is the first thing. I hope you understand. If at all you want to run the simulation, then with respect to time, this is the method. There are two type of methods to run a simulation. First method is with respect to time. I have explained you the time. Okay. Again, I am telling you, don't get confused. An input, single mission, and a source. Even the model is this. What happened? Okay, delete. Even the model is this much simple, we need to follow the same principle: arrange, distribute horizontally. Now see, I am resetting the model. One day, reset, run. Sorry, reset it, control. I forgot to give the connectors. Event controller, reset it, run the simulation. This model will run up to 24 hours or a day. 19, 20, 21, 22, 23, 24. The length of model is not matters a play, I mean not place a key role here. So what is the time you are defining, that will be placing a key role here. So you want to run the model, whether it's a smaller model or larger model. So if at all you want to run it for a one day, it will run no matter what. Okay, this is the first method. Now some of you has asked this question. Here it is visible, I mean the station is working, so the green color is representing. Now why the drain is not representing any color? Drain is like a bin where it is collecting the material. From this there will be no any connecting. Even though if see I am placing a mission, if at all I want to connect the drain with a station, it is not going to possible. Why? Because drain is like a output. From output we cannot collect the again some connection. That is why drain is like a end part of the process. So we can't define anything from a drain. That is why there is no any representation from this. Okay, even though if at all you want to, okay, I will tell you the statistics later. This is the first method. Okay, now I have run the
Excuse me,
simulation.
sir.
Yes.
Sir, if we have to use means one process's output as a input of another, so we have to connect direct the missions. Means we have to connect the missions directly.
No, connect the machine directly. Yes, see,
Okay,
uh,
sir.
this is the station and there is one more like this. Okay, this is process 1 and this is process 2. After this the part need to enter here, then I can connect, or by using a connector, by using a conveyor, by I can use a lift, I can use a forklift, whatever the different terms of material handling, I can use them and I can change the material from that station to this station. That is how exactly. If you use a drain, which means it is end, it is end of the process, so you cannot collect the part
Okay,
from
sir.
the drain. Fine. Now this was done. Now there is one more thing here. Align horizontal, align, distribute horizontal. Fine, now I'm connecting. Okay, now see what is the time I have given here.
1 day, sir.
1 day.
1 hour.
1 hour.
Seconds, minutes, hours, so it is 1 hour. So for running a simulation I need to reset the simulation and I can run it. Done. Now how many parts I have produced? First thing I have tell you how to run a simulation with respect to time. Instantly after completing this, there is one more, that is the next topic, that is nothing but how many parts I have produced by using this process.
For
Depends on rate of production.
That can be defined by using this drain statistics. Okay, drain is nothing but output. So I am resetting the simulation and run the simulation, so it was stopped. So once the simulation was done, then I need to double click this drain. Okay, so this is the drain, so I am double clicking it. So once I double click this one, there is this option time, setup, failure control, statistics, type statistics. So in that I need to go to statistics. So go to statistics. See here how many parts entered here. Is it visible?
Not clearly visible, sir.
356, sir.
356, I think.
Yes, it's 356. That is what exactly the drain has collected in 1 hour. So if you check the type statistics, throughput, I hope you remember this word throughput. The parts entered into
Yes.
this mission. See, the drain has 356 parts as of now. So by calculating this throughput, I mean total throughput is this much. So with respect to that, if at all you have calculated, then throughput per minute is 5.93. Throughput per hour is 356. Throughput per day is 8544. So this is with respect to the statistics. So but in general what happened at the end of an hour, so you have received 356 parts that was defined here. Entries and exits. Why there will be common, I mean entries is 356 and exits is also 356. Why both are same here?
Drain, because it is a drain, sir.
Drain. So there is no any connecting between, I mean from the drain. That is why entries and exits will be same in 356. Now what will be happen if I check the station? Okay, see I have checked this one. Now I want to check how many parts this station has produced. So for that same I need to double click the station, then here I need to go to which tab? Statistics.
Statistics.
Okay, I need to go to statistics tab. See here how many entries?
360.
360 parts have
360.
entered. How many parts have exit from this one? 359.
59.
So there is already one part that is waiting here. That is why it is green in color. So there are 360 parts that are entered into the mission, and out of 360, 359 parts have exited from this station. Now what will be the throughput of this mission?
360.
Yes, 360 is the throughput. Okay, so which means the parts entered into that mission is nothing but a throughput. So the mission statistics is this one: entry 360, exit is 359. Now what will be happen to station 1?
One less.
Statistics.
So
Entry is
359
359. See
throughputs.
here, 359 exits and 359 entered. Exits is 358. Now what will be happen to this one? 358, 357. If I click this one, station 3, 356. Now what will be the drain?
356.
If you click the statistics, 356. Clear? See,
Yes, sir.
first step is running the simulation with respect to time. So first you need to create a simple model like this. I have created a simple model like this. Now I want to run the simulation with respect to time. So whether it may be 1 hour, 2 hour, 1 minute, even though if it is for 30 seconds, you need to give here and you need to run the simulation. Once the simulation was done, I mean don't reset it. So before resetting it, open the statistics to check how many parts you have manufactured by using this process. So if at all you want to check the complete statistics per drain, so directly you can double click on the drain and you can go to statistics and you can be getting, so what will be the throughput, how many parts it has produced by this process at the end of 1 hour, that can be defined in this process. So if you want each and individual statistics, then you can double click on the mission, station 1, station 2, station 3, like you can double click on it and you can go to the statistics and there will be entries and exits. You need to consider the exit. Okay, how many parts are exited from the station, you can consider that by using these statistics. Okay, with which you can, you will be having an idea that, so it after an hour, how many parts have produced. So by using this process, after an hour, so how many parts I have produced? 350 parts I have completely produced. Okay, but what will be the input of the plant? How many parts I have given input to this one?
361, 360.
For that, if at all you want to check that also, directly you can use by using this one. So what is the station? This is the station. Where is the station? This one. So what is the station entries? 360. So 360 parts have entered. So if I click this one, statistics, see how many parts are exited from the source?
360.
360. So which means out of 360, how many parts have produced? 356 parts have produced. So that is what exactly your complete statistics for end of this process at an hour. Clear?
Yes, sir.
This is first.
Sir,
Yes.
suppose it if we are at the end of the and we are closing the missions, so then also we have to define that throughput.
Yes. We have to define the throughput. Why? Because we need to maintain the statistics after completing a day. So how many parts I have produced, how many parts are still in work in progress. I will say these as work in progress. Station 1, station 2, station 3, station 4. There are 4 parts that are left here. Those 4 are nothing but my WIP inventory, WIP. I hope you remember, I have already raised the
Yes, sir.
topic. WIP is nothing but work in progress. See, now the part is waiting for this mission. At the same time, this mission. So once these 4 parts are also completed, then complete process was done. Why? Because these 4 are still waiting for the work. That is WIP. Okay. So we will be considering this as the output. The input is 360. Okay. Now I don't want all these things. I am just cutting it. This is first method. Is it clear? The first method? The first method is running the simulation with respect to time. Okay. Now
Yes, sir.
I don't want run my simulation with respect to time. Now what will happen? I have deleted the time here and time. If I run the simulation, what will happen?
So production will not stop. It will means resume
It will
producing.
continuously produce the parts. Now I don't want like that. So what is the previous throughput of the drain? By using this process, how many parts I have produced at an end an hour?
356.
356 or 356. Okay. Now I want to run this model for 500 parts, only for 500 parts. I don't want time. Okay. I want to produce 500 parts at the end of the day or at the end of the process. So I want only 500 parts for me. So how much time it will take, I don't mind. Okay, for that type of simulations. Okay, the first method is with respect to time, and second method is with respect to the quantity of the products which we are going to produce. Okay, these are the two methods that will be used in the plant simulation. First is with respect to time, second one is with respect to quantity. So now I want to produce 500 parts. So for that, okay, for defining that one, if at all I want to produce 500 parts, then how much input I need to have? See, simple thing.
505.
Yes. I want to produce 500 parts, which means I need to have 500 input. So I need to give that in the input only. So I need to give input. So where is the input here? In this model, where is the input?
Source.
Okay. Double click on the source. Then we will be having this pop-up. Here there is one thing here, time of creation, the important thing here, time of creation interval adjustable. Okay, in that, so there is a ribbon here, so you need to drop down ribbon, click on this one, and there is one thing here, number adjustable. So you need to click that number adjustable. Okay, which means it is asking me how many parts you want to prepare or how many ones you want to produce from this input. Here I am defining how many parts I want to produce, 500. Apply. Okay, I'm explaining again. So if at all you want to define the simulation with respect to quantity, then you need to enter into source. From the source only we are defining the input, right? So from the source, you need to double click on the source, and here in the second one, type of creation. So default it will be interval adjustable. So you need to enter into number adjustable. Okay, in that number adjustable, you can define how many parts you want to produce. So here, see, I am producing 356, right? Previous cycle 356. I'm just defining 356. Apply. Okay. Now how I have defined 356 parts. So here the same thing again. So we need to reset the simulation and you need to run it. What happened? How much time it was produced for 356 parts?
So 1 hour.
59 minutes 50 seconds. Okay. If I check each and every mission statistics, so what is the statistics here? 356. But what is the this statistics for the previous model? How many parts I have produced from this mission station, first mission?
So 360.
For the second mission, see, if I check the second mission, what is the part here? 356. If I check the drain, 356. Clear? This is with respect to parts. Okay, cancel, cancel. Now I want to see here, instead of 360, I want to run this model for 360 instead of 356. Now how much time it will be? So I am resetting the simulation, run it. 1 hour 30 seconds, so that at the end of this one, when I open the drain, there will be having 360 parts. Okay, similarly I need to reset the simulation. Here I want to run the simulation for 500 parts. Okay, here my quantity is fixed. I mean, I have a market, I have a demand to produce 500 parts. Some customer is asking me to produce only 500 parts, not more than that. So I will be considering 10 reject piece, and together I will be giving 510. Okay, for safety purpose. Apply. Okay, and reset the simulation and run the simulation. How much time it will take for me to produce 5 to 10 parts?
So 1 hour 25 minutes and
1
30
hour 25
seconds.
minutes. Now what will be happen? What is the input I have given here? 510 parts. Now each and every machine will be having 510, or there will be having any difference?
So every mission
See,
have same.
if I click the station, if I go to statistics, 510. If I click station 1, exit, there will be 510. If I click station 2, statistics, 510. Same with this one, statistics, 510. Same with the drain, statistics, 510. Clear?
So I have one
Yes,
doubt.
sir.
Yes. What is your doubt?
Earlier we have produced according to time, like 1 hour. So we got 356 as a in drain.
Hmm.
And when we defined the products, number of products 356, so we got the time like 59 minutes 50 seconds.
Hmm.
So why there was difference of 10 seconds?
Why? Because see, in the previous model, what happened? Every machine is not vacant. I mean, if I run the simulation for 1 hour, so what will be happen? This mission, this station one will going to work for 1 hour. So irrespective of parts, so whether I have produced 1,000 parts here, that doesn't matter, but this mission need to run for 1 hour, this mission need to run for 1 hour, this mission need to run for 1 hour, like that all the missions are running for 1 hour. At the end of an hour, what will be happen? The parts entered into this will be collected, the statistics. That is why I have achieved only 356 parts here. Here what happened? There is already a part here, there is already a part here, there is already a work in progress part here. That is why at the end of an hour, so what happened here in the previous model, there are 356 parts I have produced, whereas 4 parts are still with the mission. Those are 10 seconds. That is why there will be having that 10 minutes of delay. I mean 10 seconds of delay. Here in this process, what happened? I have defined 356 parts only. So after 356th part, this mission was stopped. After 356 part, this mission was stopped. After 356, this mission was stopped. Like the same, it was stopped at 356th part. So then the mission is having, I mean, this drain is completed the part in 10 seconds only, less than 10 seconds.
Okay, sir.
Okay, so these are the two different methods. I hope you understand. First is with respect to time, and second is with respect to quantity. So if the demand is there, if the number of quantity is fixed, if at all you want to produce 500 parts or 520 parts, whatever the x figure, the quantity is fixed. then you need to run the simulation with respect to quantity. In that, what will be happen? This complete process will work with respect to that quantity only. Once the final part, even the 509th part is there, 510th part is came here, then only the process will going to stop. That is what exactly in this one. So that is quantity. If we run the model with respect to time, then what will be happen? So we need to define a time here. So based upon the time, even the till last second it will work. So it won't consider even this work in progress or some other works. Even though if it is in the middle of a process, if this mission is having some 2 hours of processing time, and I want to run the I want to stop the simulation after 1 hour. Now what will be happen to this part which is already in processing? What will be happened? See, this mission is half an hour, half an hour, half an hour, half an hour, 4 half an hours. Processing time 30 minutes, 30 minutes, 30 minutes, 30 minutes. Now I want to run the simulation for 1 hour. Now what will be happened? Do I get any output from this one?
No, sir.
What will be? Where will be my product? Will be? Where will be the
At
product?
station 1.
At station and station 1, the product is at these two stations. Why? Because this is having half an hour processing time and this is having half an hour processing time. Now let us consider it is a 45 minutes of processing time. This mission is a 45 minutes of processing time and this mission is 45, 45, 45. Now I want to stop the simulation after an hour. What will be happen? First part will be exiting from station and it will be reaching to station 1, and after 15 minutes the process was stopped. So what will be happened here? That part is in the middle of operation and we are stopping the simulation, because of which what will be happened? The material got damaged sometimes, right?
Yes,
Yes,
sir,
sir.
got it.
Okay, that is why we are going to consider two different aspects, two different methods in the plant simulation. First method is with respect to time. If at all you want to run the simulation with respect to time, then you need to check all these on the WIP, all these things. Why? Because if you run the simulation with respect to time, then there will be having some losses also. Okay, you want to consider them, then you can consider it. If at all you want to run the simulation with respect to quantity of the products you want to produce, that can also be possible with respect to simulation. Okay, this is the first method. This is the main principle from this plant simulation. Okay, clear with this one?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Building the model also, see basic model again I am telling you, a source is a common, at the same time a drain is also common. If at all you want to use a mission, then you need to click the mission and you need to click it, it will be pasted. Same, click and click, click and click. Fine. Now I am having these many missions. How to align them?
Right click
Right
and
click,
arrange.
align, or
So
arrange.
horizontal alignment or vertical alignment?
Yes, right click and there is an option arrange icons, in that align horizontal. Okay, it was aligned. Now if at all I want to distribute them, then same option arrange icons and distribute horizontal, then it will be distributed. Okay, so now I have created. Now what is the next step I need to do after placing these missions? The placement of missions was done.
Connecting.
Connectors.
Okay, so I am using connector 1 to 2, 1 to 2. Okay, connected. Now I want to drag this complete assembly to this one, then select everything, hold. Okay, here you have builded the model, I mean you have created the model. Now you want to run the simulation, so that you can define. So you want to run the simulation with respect to time or with respect to quantity, that you need to define. If at all you want to run the simulation with respect to time, then you need to go to the event controller. Event controller is mandatory for both cases. Here, this part always first reduce the speed, then reset it, then go for settings. If at all you want to run the simulation with respect to time, then you need to define here. So the format you need to consider is days, hours, minutes and seconds. Based upon that only you need to define your time. Okay. So if you directly paste some number 250 here, so what will be happen? It will be considered as seconds. So totally it will be converted to 4 minutes and seconds. So if you want to give minutes, then 5 and you need to use a semicolon. Then it will be converted like this. It will be minutes. Same, if at all you want to give some hours, then 8, you need to press double. Then it will be considered as hours. If at all you want to consider it as days, I mean, then you need to give some this one and 3. Okay, this is 3 days. Like that you need to define your end day. Now I want to run the simulation for with respect to hours. I want to use some 6. Okay, 6 hours. Fine. Now I have given this one, reset it. I can run the simulation. The simulation will work based upon that only. If at all I want to increase the speed, you can increase the speed, and it was visible here. After 6 hours, it is going to complete. And how can you supposed to check the statistics? Mission statistics or drain statistics, how can you supposed to check that?
Double click.
Yes. So whatever the component you want to check, if at all you want to check this 4 or 6, then double click on the component and go to statistics tab. In the statistics tab, you will be having these things, entries, how many entries and how many exited. So the entries will be throughput and exit will be the next input to the plant source. If you go to the drain and same statistics, 2156. Throughput per hour, throughput is 2156 total throughput. Throughput power per hour is 359. So this is what exactly the throughput statistics will be. Like you can define, this is the first method with respect to time. Now I don't want to run the simulation with respect to time. Then I am deleting it, apply. Okay. Then here I need to see, before giving this, you need to reset the simulation. Then open source. Here, what is the thing you need to opt here? I want to run the simulation with respect to quantity. Now, how can we supposed to do that?
There in amount section.
In this time of creation, see there is this time of creation. Kindly note it down. Time of creation section. There is a ribbon here. Drop down menu is there. In that you need to go for number adjustable. Okay. You need to click the number adjustable here. How many pieces you want? Whether you want 100, whether you want 1000. I want 1100 parts. Apply. Okay. Now reset the simulation and run it. What is end time? 3 hours, 3 minutes and 50
3
seconds.
minutes.
If I check the statistics, 1100 parts. Okay, that is what exactly the simulation is. Okay, this is the basic principle. Even the model is having some 100 missions, 200 missions, 10,000 missions also. This is the same basic principle you need to follow. Either you want to run the simulation with respect to time, or you want to run the simulation with respect to number of parts. Okay, in generally larger plants will use the time only. Why? Because every plant will work with respect to time only. So I want to run the simulation for 7 days, I mean a week. I want to check how the behavior, then I am giving 7 here. And okay, now what happens here? What is the source I have given here? What is the quantity I have defined here?
Number adjustable.
1100 I have the quantity defined. What is the time I have defined here?
7 days.
7 days.
Now if I reset the simulation, run it, what will happen? Why it is not running? See here, according to this one, what I have defined, 7 days. So this model is going to run for 7 days without any halt. But here, after 3 hours, this process was stopped. Why it was stopped?
Number has produced.
Number has
So we have
produced.
Because
received the output.
The output is satisfied.
So
Okay.
less availability of input.
Yes. Here, what is the condition we have defined? The input we have defined is only 1100 parts is the input we have defined, which means only input is given 1100. That is why after this time it was stopped. Now, if at all you want to maintain that, again run interval adjustable, and this will be -1. -1 is like, I will explain you this -1 in later slides, but I will give you overall overview. -1 is like a least availability, which means whenever a part is exiting from this one, so automatically there is a part that will be ready to dispatch. That is what exactly -1 will be. So least availability, I mean the machine will be ready to deliver the part whenever the one part is entered into, I mean exiting from the source, so automatically second part will be at that station instantly. That is what -1 will be. So default value is -1. Apply. Okay, if I run the simulation, see what will happen. Now see it's running, right? It will work.
Sir, so can we define the output at drain also?
No, it is a predetermined. Why? Because with respect to time or with respect to quantity, this drain will be calculated. We can't give anything to drain. We can't control the drain.
Okay, sir.
Okay, see this is the method. Clear? This is the first basic method. Next one, how to change the names.
Excuse me, sir.
Yes,
Excuse me, sir.
yes.
So can we have more than one trains? Means suppose we same process we are producing two different type kind of products. So
Pause. Drain one statistics. This status. What happened? 1126, 1126, 1126. If you check this mission,
Yes, sir.
okay, sir, got it.
which means equal distributed. You can have multiple drains, you can have multiple sources. That is like a advanced modeling, I mean. Okay, so you can use multiple source also here. From each and every mission you can use a source. What will be happen now if I give multiple sources? Now you tell me, if I give multiple sources to station 4, what will be happen? What will going to happen?
So buffering.
Hmm? There will be
So
having lot
block
of,
हो सकता
yes, there will be having lot of bottlenecks in the process. Why? Because I am giving continuously input. Instantly I am giving more than the deserved input, and the mission process and the missions which I am having is very limited, and they are already occupied with the mission, already occupied with the inputs. That is why there will be having lot of blockages. So based upon the model, we are going to define the source as well as drain. That's it. For drain, no problem. See, you can use any n number of drains. Why? Because from drain there will be no any input, no any input will be collected. So different process it will be collected from the drain. That can be possible. But for a source, you need to consider. So before giving, if at all I give two sources, what will be happen? Two inputs will be coming to station 4. So that what will be happen? This station 4 will be having some default principle. One part will be entered from source one part will be entered from source. Like it will be having some principle. So that what will be happen again? There will be having a bottleneck and blockage will be there. So to eliminate that, if it is needed in the process, then we need to use multiple sources or multiple drains based upon the condition. Clear?
Yes, sir.
Now how can we supposed to rename these things? I don't want is a source one. How can I redefine it?
right click and rename.
Yes, there is an option rename, and you can change it to in. Same with this also. Rename, I will be using m1. Okay, similarly m2, similarly m3. Okay, now this one. Okay, this will be my rename out. Clear so far with this one?
Yes, sir.
Okay, now I will be entering into one more topic, important topic in this one. So once the model was created, once we have defined the, I mean simulation, which means whether it respect to quantity or with respect to time, so we know that also. Then there is one of the important thing that is called as a processing time. What is a processing time?
So the time a mission has taken to produce a product.
Yes, Processing time is nothing but a simply operating time. Let us say operating time. Okay, operating time of each and every mission. To check that one, so you need to double click on this one mission. See, there is a processing time. So what is this one?
10 seconds.
In a real, is it? I mean, 10 seconds will be acceptable. If there is CNC
No,
mission is
sir.
there, let us consider it
No,
is a
sir.
CNC mission. So will the work is going to happen in 10 seconds? No, it
No,
won't
sir.
No, sir.
happen. So now you need to define it. See, if I click this one, there is a format here: day, hours, minutes, seconds. Now, based upon that one, let us say some this mission is having some 2 minutes of processing time. Two, I'm giving semicolon, apply, which means 2 minutes. Okay, okay. Mission one I have defined. Mission two, say some time.
4 minutes.
Okay, four, apply. Mission three, let us say 1 minute. Again, mission four, sometime,
2 2 minutes.
yeah, 2 minutes. Apply. Now, according to you, what will happen now? What is the processing time of this mission? 2 minutes. This mission, 4 minutes. This one, 1 minute, and this one, 2 minutes. Now, for a part, okay, if there is only one part, how much time it will take to reach this location? If there is only one part, how much time it will take?
9 minutes.
Okay, so it is 2, it is 4, and this one is 1, and this one. Calculate everything. 2 plus 3, 7, 9 minutes. It will take 9 minutes to produce a part from this station, right? Let us, we'll check that also. Where is this event controller? Here I am completely eliminating the time, apply. Here interval adjustable, so number adjustable, I'm giving only one part. Okay, apply, reset. If I run the simulation, see, clear, based upon the time you have defined, the part entered here, the part exited. Now I don't want this one, I'm changing it interval adjustable, and it will be -1. Okay, settings. Now I want to run the simulation for a day. Reset it, run it. How many parts it was produced? See how many parts it was produced? 13 parts.
13.
This is the exact, I mean, actual characteristics. Actual, what will happen? So you need to define these times. These times will be considered with respect to the process which you are defining. If there is a drilling application, the drilling application will definitely take 2 minutes or 3 minutes or 4 minutes. So based upon the mission, it will be. If there is a milling application is there, it will take less time to do a face milling operation. So this much. If there is a chamfer application is there, then you need to have this much time. Like based upon the application, we need to define the processing time. So if it is a common processing time is there, if it is 2, 2, 2, 2, then you will be having more number of parts. But here you will be having variable processing times, different processing times, because of which what will be happened, this will be defined. Okay, the total parts that are produced is 13 only. Got it? Now in this process, will there be any blockage or not? Now you tell me that. We have defined this process. In this process, will there be any blockage or not, or any waiting phase will be there or not?
Yes, there will be
Yes,
a
sir.
waiting
On
because
M1 and M3.
And MM3 waiting phase,
Yes, sir.
where will be blocking will be there.
blocking will be at M1 between M1 and M2 because M2 will take time to process. So material will get collected between M1 and M2.
Fine, correct. So to define that, we will be using these things. Chart. Okay. For chart, you need to click here. Okay. You need to paste here. Have a look on this one. Tomorrow I will explain you how to do this one. Okay. See here. I have defined a chart. Now I need to reset the simulation and run the simulation. Mission 1 is having blocked phase. Mission 2 is running perfectly. Mission 3 is having waiting phase. Mission 4 is also having waiting phase. I hope you know why. Why? Because this mission is having 2 minutes of processing time, whereas second mission is having 4 minutes of processing time. Because of the 4 minutes of processing time, what happened here? This mission is producing the part, and it is waiting for this mission. That is why there will be having lot of bottleneck here. Blockage will be there. Okay. Whereas what will be happen with M3? Why there is a lot of waiting? This much of gray face in M3.
So because M4 has means more time of processing than M3.
No, waiting, not
Because M2 is
blocking.
not supplying the adequate amount to M3.
Yes.
So it will have to wait.
M2 is having 4 minutes of processing time, whereas M3 is having 1 minute of processing time. So why it happened with this is, so for every 4 minutes there is a part that will be entering into M3. At the same time, once the part entered, after a minute this part will be exiting from this M3. So the rest 3 minutes this mission is in waiting phase. It is waiting for this part. Again, after 3 minutes, it will be collecting a part from this M2. At the same time, after receiving a part from M2, again same thing will be happening. After 1 minute, so it will be producing a part to M4, and the rest 3 minutes it will be waiting. That is why M3 will be having a lot of waiting phase when
So
compared to
then
this.
why M2 is having a waiting phase
M2 is having waiting phase. Where exactly it is waiting phase? See, this much
at the top?
limited. Yes, that is why, because this is having 1 minute of processing time. Where is this one? M1, 2 minutes of processing time. Maybe sometimes what will be happened at the least time, it will be having a limited, waiting phase. Whenever it is necessary, so it will be still producing, or for this delivering, for the material handling, this much of small, minute waiting phase will be there. Okay. So based upon this, we are going to calculate further. Now what happened? I am having a chart with me. Now I am having a chart. How can I supposed to redefine it? If at all I want to reduce the waiting phase, reduce the blocking phase, how can I do that?
Two machines in place of M2.
So buffer use कर लेंगे.
Those things will be discussed in tomorrow's session regarding the charts and everything. Okay. So why? Because charts is an advanced topic. You need to familiar with initial things first. Then only these charts will be easy for you. That is why I have shown you, but I haven't entered into in depth. Okay. Now don't worry about the charts. I will explain you in tomorrow's session what exactly we need to do with the charts. Now we have the missions, we have everything, connectors. Now what is the next thing? That's it, guys, for basic first session. I hope this is visible, this is fine, and this is enough also. From tomorrow onwards, from tomorrow's session, we are going to discuss this robot, how to use a robot, what is the necessity of a robot. After that, how to use a conveyor. So if at all I'm using a conveyor, how we need to use the conveyors, how to give the load. And after that, we will be discussing about what are these charts. Tomorrow we will going to discuss these three topics in detail. Okay. Today, try to practice all these things which we have discussed, create number of models. So you need to familiar with these things. Okay. For tomorrow. Clear? There is no any
Okay, sir.
assignment, but you need to create your different models. Hardly it will take 5 minutes or 10 minutes to explore the software and everything. So what we have discussed today, and try to build different models with respect to alignment, with respect to horizontal alignment, horizontal distribution, same vertical alignment, vertical distribution, different name changing things. Then create a simple model with respect to time, create a simple model with respect to quantity, and try to run it. And don't use this chart as of now. Okay. But up to this section, try using it and make thorough on all these things. Still, if you are having any doubt, don't worry. In the tomorrow's session, in the earlier, in the early minutes, we're going to discuss any doubts if you have. Okay.
Okay, sir.
Fine. Someone who is not having the software with them, kindly try to, take guidance from your friends or those who are using Mac ID. Try to use some alternative laptops or PCs. Why? Because this software is not available with Mac. I got the information that also. So try to use some other source for this one. Try to practice it as much as you can, so that what will be happen, this basic, this is the basic thing. If you thorough with this basic thing, then the rest will be easier for you. Why? Because this is the main thing. Whatever the model you are going to produce, if you are producing some 100 components or 200 components, this is the basic principle you want to follow. So once you are familiar with these basic things, then don't worry. So the missions number will be increasing, the rest will be same. Okay. That's it from my side for today's session. Just practice it completely on the things which we have discussed today. If you are having any doubt, kindly ask me tomorrow. Clear?
Yes, sir.
That's
Yes,
it.
sir.
That's it from my side,
Sure.
guys.
Thank you,
Thank
sir.
you, sir. Have a
Thank
great day, sir.
Okay, thank you. Have a great day to you too. Bye,
Thank you,
guys.
sir.
Okay, bye.
Thank you so